Start.
Good morning, Monita. Welcome back to webinar classes. Today, Mathematics 1A, Session 6. Yesterday, we have studied what is transpose of a matrix, symmetric matrix, skew symmetric matrix, their properties, and a few problems based on them. Also we have studied the determinant of a 2 by 2 square matrix. Today we will be going to study what is meant by minor, cofactor, determinant of 3 by 3 matrix, and adjoint matrix, also inverse of a 3 by 3 square matrix. Before going to that, just two problems we will observe based on the yesterday's concepts, symmetric matrix and skew symmetric matrix. So see here, if A is equals to 7, 5, 4, 5, 2, x, 3, 1, minus 1, 0 is a symmetric matrix, then x is equals to how much? Remember once, if A is equals to 7, 5, 4, 5, 2, x, 4 minus 1, 0 is a symmetric matrix, then what is the value of x? So you need to be careful. Yesterday we have studied what is meant by symmetric matrix. Symmetric matrix is nothing but when we do transpose of given matrix, it should be again equals to itself. See here, given that A transpose is equals to A. Given that A transpose, since they said it is a symmetric matrix, so we need to take that A transpose is equals to A. Now what will be the A transpose here? A transpose, the rows and the columns are to be interchanged. So see here, first row is to be written as first column, second row is to be written as second column, third row is to be written as third column. This is A transpose, which must be equated to A. So A is 7, 5, 4, 5, 2x, 4 minus 1, 0. Now, observe once, 7, 5, 4, 7, 5, 4. 5, 2 minus 1, 5, 2, x. X means here, corresponding elements of these two matrices are to be equated. So x is equals to minus 1. Otherwise, here 4x 0, 4 minus 1, 0. Here also, by equating the corresponding elements, we will be getting the value. So x is equals to minus 1. So when the given matrix is a symmetric matrix, how to find the unknown variable? So here in this way, we need to find out the unknown variable value when we mention that the given matrix is a symmetric matrix. Next, let us go for the another example. If A is equals to 0, 5, 3, minus 5, 0, 2, k minus 2, 0 is a skew symmetric matrix. Then k is equals to how much? K is equals to 0, 5, 3 minus 5, 0, 2 k minus 2, 0 is a skew symmetric matrix. Then what is the value of k? Remember one thing, by definition of skew symmetric matrix, so A transpose is equals to what you need to do? Minus E by definition of skew symmetric matrix. So here, when this is the matrix A, its transpose is first row is to be written as first column. So 0, 5, 3. Second row is to be written as second column minus 502. And third row is to be written as third column k minus 20 is equals to minus of. So the given matrix is 0, 5, 3 minus 502 k minus 20. So which is equals to minus is nothing but minus 1 is a scalar is to be multiplied by every element inside this matrix. So minus of 0 will be 0, minus of 5 will be minus 5, minus 3. Next, minus of minus 5 is 5, 0, minus 2, minus k, 2 and 0. Which is equals to left side will be 0 minus 5k, 5, 0 minus 2, 3, 2, 3, 2 and 0. So whenever these two matrices are equal, we need to equate the corresponding elements. So when we are equating the corresponding elements, this third row first column element will be equals to third row first column element here. So 3 is equals to minus k. Obviously k is equals to 3. Otherwise, first row third column element directly k is equals to minus 3. So this is the way whenever they mention that the given matrix is a skew symmetric matrix and to find out the unknown variable value. So next, yesterday we have studied what is meant by determinant of a skew symmetric. This determinant of a 2 by 2 square matrix. Now, to find out the determinant of a 3 by 3 square matrix, we must know what is meant by minor of an element, cofactor of an element, cofactors matrix, etc. So, for finding the determinant, we must need minor and cofactor concept. First, let us see what is meant by minor and what is meant by cofactor. Later, we will go for the determinant. So, now, minor. What is meant by minor? For example, A is equals to 2 minus 4, 7, 1 minus 5, 0, 2, 3, 1, 4. For example, this is a square matrix of order 3. How to find the minor of each element of this matrix? Once we see the example, later we will give the definition. First, I wanted to find out minor of 2 is equals to. Whenever we are finding the minor of 2, what we should do? Wherever the element 2 is present, ignore, delete that row and delete that column. So when we delete that row and that column, there will be a remaining 2 by 2 square matrix. For this remaining 2 by 2 square matrix, determinant we need to find out. So minor of 2 is equals to determinant of this 2 by 2 matrix, which is equals to AD minus BC. Yesterday we have studied when A is equals to ABCD, then determinant A is equals to AD minus BC. AD minus BC. So now here minus 5 into 4 minus 0 into 1. So which is equals to minus 20 minus 0, which is equals to minus 20. Here, minus 20 is the minor of this element 2. Now, same way, how to find the cofactor of this 2? So, cofactor of 2 is equals to minor must be multiplied by, suppose minor is how much here? Minus 20. This minor is to be multiplied by minus 1 power I plus j. What is meant by I and j here? Suppose the element 2 I am assuming as A and J. A and J is an element. So this element is in ith row and jth column. Aij is an element which indicates its position, that it is in ith row and jth column. So cofactor of 2 is equals to minus 1 power. This 2 is in which row plus which column? First row, first column. Here in this case, so minus 1 power, so 1 plus 1, 2 is in first row and first column. So I is equals to 1, j is equals to 1. And then into minor. So minus 1 power 2 is nothing but 1 into minus 20 is equals to minus 20. In this way, we need to find out the minor of an element of a matrix and the cofactor of an element of a matrix. Now, I will give you one more element. We will find out the minor and cofactor. Later, I will try to define what is minor and what is cofactor. Let us take minor of this one. So, minor of 1 is equals to. So, when we are finding the minor of 1, what we should do? Wherever the 1 is present, that row and that column both to be ignored. And this column and this row is gone. Means what is the rest of the 2 by 2 matrix? 2, 7, 1, 0. So 2, 7, 1, 0. So its determinant will be defined of. So AD minus AC. 2 into 0 minus 7 into 1. So 2 zeros, 0 minus 7 is equals to 7. So when we are finding the minor of 1, ignore the row and ignore the column in which 1 is present. The rest of the 2 by 2 matrix determinant, when you find out that itself is the minor of the element 1. Now what is cofactor of 1? Cofactor of 1 is equals to minus 1 power. So this 1 is present in which row? Third row. And which column? Second column. So minus 1 power 3 plus 2 into what is its minor? Minus 7. So minus 1 power 3 plus 2 is 5. So minus 1 power 5 is nothing but minus 1 into minus 7. So minus 1 into minus 7 is equals to 7. This is the way how to find the minor and cofactor of each element of a given square matrix. Now, let us come to the minor definition. Minor, suppose Aij is an element of matrix A. By ignoring ith column and jth row, ith column and jth row are deleted, and the determinant of the rest of the 2 by 2 matrix is called as minor of the element Aij. Minor of 2. Minor of an element is defined as by deleting the row and the column in which the element is present. And the determinant of the rest of the 2 by 2 matrix is called as minor. Now, what is meant by cofactor? When the element is in ith row and the jth column, then minor multiplied by minus 1 power I plus j, the result to be obtained is called as cofactor of a given matrix. So here in this matrix, when 9 elements are there, for each element we can find out the minor. For each element we can find out the. Okay, now I hope minor concept and cofactor concept is clear. Out of 9 elements, for only 2 elements, this element and this element, I have calculated the minor and the cofactor. Same way, we can find out the minor and cofactor for every element of this matrix. Next concept is what is meant by cofactors matrix. Cofactor matrix. For example, A is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3 is a 3 by 3 is pair matrix. Now, it's a cofactors. Suppose cofactor matrix of A is equals to A1 cofactor I am representing, denoting with capital A1. B1 cofactor is represented with capital B1. Same way, capital C1, capital A2, capital B2, capital C2, capital A3, capital B3, capital C3. We need to find out the cofactor for all these 9 elements individually. Once you obtain the cofactors of these 9 elements, those cofactors are written in their respective places. Then the matrix so formed is called as a cofactor matrix of given matrix. So how to define cofactor matrix? Cofactor matrix of a given matrix A is obtained by replacing all the elements of the given matrix by their respective cofactors. Such a matrix is a cofactors matrix. For your kind information, if this cofactors matrix A is transposed, so the transpose of this cofactor matrix is called as adjoint matrix. Adjoint matrix of A is equals to. So once you obtain the cofactor matrix, what we should do? It is to be transposed. Transpose of this matrix. First row is to be written as first column. Second row is to be written as second column. Third row is to be written as third column. So this is a matrix which is called as adjoint matrix of a given matrix. I hope the concept is clear. What is meant by cofactors matrix and what is meant by adjoint matrix? Cofactor matrix is a matrix obtained by replacing all the elements of a given matrix by their respective cofactors. Next, the transpose of a cofactor matrix of a given matrix is called as adjoint matrix of the given matrix. So now we have studied what is meant by minor, what is meant by cofactor, what is meant by cofactor matrix, and what is meant by adjoint matrix. Now we will do one problem for these concepts. So find the example. Find the adjoint matrix of A is equals to 7, 5, minus 2, 1, 5, 1, 4, 3, 2, 1, 5. So here is a matrix given. We need to find out adjoint matrix for this. To find the adjoint matrix, we need to find its cofactors, minus cofactors, and transpose of cofactors matrix will be nothing but adjoint matrix of this given matrix. So here, solution. A is equals to 7, 5, minus 2, 1, 4, 3, 2, 1, 5. First, let us find out cofactors for all the 9 elements. Cofactor of 7 is equal to minus 1. Directly I am writing. Minus 1 power. 7 is in ith column. Means first row and first column. Into what is this minor? Minor of 7 means we need to delete this row, delete this column, and the rest of the 2 by 2 matrix determined 4, 3, 1, 5. So this is the minor. This minor is multiplied by minus 1 power I plus j. The result what you get is a cofactor of this 7. So which is equals to minus 1 power 2 into AD minus BC. Yesterday we have studied ABCD is a square matrix. Its determinant is denoted by AD minus BC. So 4 into 5 minus 3 into 1, which is equals to minus 1 whole square is 1, 4 5 are 20, minus 3 1 is 3, which is equal to 7. 17 is the cofactor of 7. Same way, cofactor of 5 is equals to minus 1 power. 5 is in first column but in second row. So now, what will be its minor? Ignore this row, ignore this column. Left over 4 elements form a 2 by 2 matrix. Its determinant we need to find out. 5, this column and this row if you ignore. So the rest of the 2 by 2 square matrix is 1, 3, 2, 5, which is equals to minus 1 whole cube AD minus BC. We do 1 into 5 minus 3 into 2, which is equals to minus 1 whole cube is 1, sorry, minus 1 into 1 5 is 5 minus 3 2 is 6. Minus 1 into again 5 minus 6 is minus 1, which is equals to 1. So 5 also we found the cofactors matrix. Next, cofactor of minus 2 is equals to minus 1 power. Minus 2 is in first row and third column. So first row and third column into, when minus 2 wherever it is present, ignore this row and this column. Left over 2 by 2 matrix, determinant 1 4 2 1, which is equals to minus 1 power 1 plus 3 is 4 into AD minus BC. 1 ones is 1 minus 4 twos, which is equals to minus 1 power 4 is 1. 1 ones is 1 minus 4 twos 8. So which is equals to minus 7 into 1 is minus 7. So far we could find out 3 elements cofactors. There is no other shortcut. We need to find out the cofactors for all the 9 elements. So now you see cofactor matrix. Sorry, cofactor of 1 is equal to this element 1 is equals to minus 1 power. This is in second row, first column. Minus 1 power 2 plus 1 into this row and this column if you ignore. So these are the 4 elements which are forming a 2 by 2 square matrix. So 5 minus 2, 1, 5 is equals to minus 1 power 3 into AD minus BC. 5 into 5 minus 2 into 1, which is equals to minus 1 whole cube is minus 1. Next 5 5 is 25 minus 2 into 1 is minus 2 of minus will become plus 2. 25 plus 2 is 27. 27 into minus 1 is equals to minus 27. Now 4 elements we could find out the cofactors. Next 5th element, cofactor of 4 is equals to minus 1 power. 4 is in second row and second column. So minus 1 power 5 into this row and this column if you ignore. Rest of the 4 elements 7 minus 2, 2, 5. 7 minus 2, 2, 5. So this is the minor of this element. So minus 1 power 4 into AD minus BC. 7 into 5 minus 2 into. So now we will be getting minus 1 power 4 is nothing but 1. Next 7 5 is 35. Minus 2 into 2 minus 4 of minus will become plus 4, which is equals to 39. 35 plus 4 is equals to 39. Next, cofactor of 3 is equals to minus 1 power. 3 is in second row, third column. So 2 plus 3 into 2 plus 3 into. When this row and this column is ignored, rest of the 4 elements are forming a 2 by 2 square matrix. So 7, 5, 2, 1 is equals to minus 1 power. 2 plus 3 is 5 into 2 plus 3 is 5 into 7 into 1 minus 5 into 2. 7 into 1 minus 5 into 2, which is equals to minus 1 power 5 will become how much? Minus 1. 7 ones is 7 minus 5 twos is 10. So this is minus 3 into minus 1 will be obviously 3. So now we could find out the cofactors for only 6 elements. So now rest of the 3 elements we need to find out. So I will write here cofactors matrix. Cofactors matrix of A is equals to, first, because there is a space constraint, so I will note down all these 6 cofactors at one place. Later I will find out the cofactors for the rest of the 3 elements. So 7 cofactor is to be replaced by 17. Next to 5 cofactor is 1. Next to minus 2 cofactor is minus 7. Next to 1 cofactor is 27. 4 cofactor is 39. 39. Next to 3 cofactor is 3 itself. Now I am erasing it. Now I will find out the cofactors for these 3 elements. Yes. Now cofactor of 2 is equals to minus 1 power I plus j. This is in third row, first column, into determinant of, after ignoring this row and this column, this will be the 2 by 2 matrix. 5 minus 2, 4, 3 is equals to minus 1 power 4 into AD minus this. 5 into 3 minus 2 into 4 is equals to minus 1 power 4 is equal to 1. 5 threes are 15 minus 2 fours. So this is minus 8, half minus becomes plus 8. So 23 into 1 will be 20. Next, cofactor of 1 is equal to cofactor of this one value and this one value need not be same. Same cofactor of this 5 and this one need not be same because they are in different places. So cofactors will be different. Now cofactor of this one is equals to minus 1 power. This is in third row, second column into deleting this row and this column. So 7 minus 2, 1, 3. 7 minus 2, 1, 3 is the remaining 2 by 2 square matrix, which is equals to minus 1 power 5 into 7 AD minus BC. ABCD, so its determinant is AD minus BC. So 7 into 3 minus 2 into 1, which is equal to minus 1 power 5 is minus 1. 7 3 is 21 minus 2 was 6 minus 2, half minus 2 become plus 2. So 21 plus 2 is 23. 23 into minus 1 is minus 23. Minus 23 is the cofactor of 1. Next to cofactor of 5 is equals to cofactor of 5 is equals to minus 1 power This is in third row and third column. So minus 1 power I plus j into minor. Minor means delete this row and this column. Left over 2 by 2 matrix. 7, 5, 1, 4 is equals to minus 1 power 6 into AD minus BC again. 7 into 4 minus 5 into 1. So minus 1 power 6. Minus 1 power 11 is again 1. So 1 into 7 4s 28 minus 5 1 6 5. 28 minus 5 is 23. 23 into 1 is nothing but 20. Now we would find out the cofactors of last three elements. I am writing here. Cofactors matrix of A. Last three elements 23. Next one cofactor is minus 23. 5 cofactor is 3. So this is the matrix obtained by corresponding cofactors of all the elements of the given matrix. So hence we call it as a cofactor matrix. Now, once we know the cofactor matrix, so the transpose of cofactors matrix is defined as a joint matrix of the given matrix. So cofactors matrix of A is this one. Next to adjoint matrix. Adjoint matrix of A is equals to cofactors matrix transpose. So this first row is to be written as first column, second row is to be written as second column, third row is to be written as third column. This is called the adjoint matrix of capital A. I hope the concept is clear. To find the adjoint matrix, we need to find out the cofactors matrix. To find the cofactors matrix, we need to find the cofactors for every element of the given matrix. To find the cofactor, what is the formula? Minus 1 power I plus j into the remaining 2 by 2 square matrix determinant after deleting the element present in which row and which column. So this is the way to find the adjoint matrix of a given matrix. Now we will go to determinant of a 3 by 3 matrix. So determinant of a 3 by 3 matrix. This is a very important concept. Determinant of 3 by 3 matrix. How to find out the determinant of a 3 by 3 matrix? For example, A is equals to A1, B1, C1, A2, B2, C2, A3, B3, C3 is any matrix. Determinant of this matrix is defined by the sum of the products of elements of any row or column multiplied by their corresponding cofactors. So once understand the determinant of matrix, the sum of the products of elements of any row or any column multiplied by their corresponding cofactors. If it is not clear, let us come to this example. First, what we should do, any row or any column I will take. For our convenience, I am taking first row and first row A1 into its cofactor. To find out its cofactor, what I should do is A1 cofactor, what I should do, minus 1 power I plus j, it is in first row and first column, into, ignore this row, ignore this column, left over 2 by 2 square matrix, determinant is B2 C2, B3 C3. This is the cofactor of A1 multiplied by the element A plus B1 cofactor. B1 cofactor is minus 1 power first row and second column. Ignoring this row and ignoring this column, the remaining 2 by 2 matrix is A2, C2, A3, C3. This is the cofactor of B1 multiplied by B1 plus C1 cofactor we need to find. C1 is in first row and third column. So minus 1 power first row and third column into its minus. Ignore this column and ignore this row. This is the 2 by 2 matrix. So determinant of A2, B2, A3, B3. This is the cofactor of C1 multiplied by C. Now you see the definition. The sum of the the sum of the product of elements of any row or column multiplied by their corresponding cofactors. First row elements I am taking. First row element multiplied by its cofactor plus B1 multiplied by its cofactor plus C1 multiplied by its cofactor. The result, whatever you get, is called as determinant of this matrix. So here A1 into minus 1 power 1 plus 2 is 2, minus 1 power 2 is nothing but 1 into, so this is AD minus BC concept. So B2 C3 minus B3 C2 plus B1 into minus 1 power 1 plus 2 is nothing but what? Minus 1 power 1 plus 2 is 3, minus 1 power 3 is minus 1, minus 1 into plus B1 I am taking here minus. And this determinant what I can write is A2 C3 minus A3 C2 plus minus 1 power 1 plus 3 is 4. So minus 1 power 4 is 1. 1 into C1 is C1 into determinant of 2 by 2 matrix A2 B3 minus A3 B2. This is the derived formula to find out the determinant of a 3 by 3 square matrix. In this, what is the logic? Hidden. Any row elements we are taking or any column elements we are taking, for our convenience, I have taken the first row elements. For the first row elements, corresponding to cofactors, I have multiplied their corresponding elements and sum is done. As per the definition, the sum of the product of elements of any row or any column multiplied by their corresponding cofactors is called determinant of a matrix. Determinant of a matrix. I hope the concept of determinant is clear. When you are finding the adjoint matrix, you need to find out the cofactors for all the 9 elements separately. When you are finding the determinant of 3 by 3 matrix, for only 3 elements, we need to find out the cofactors. For those 3 cofactors, we need not find out separately. Or you find out separately and later you multiply those cofactors with the corresponding elements of the row. Otherwise, instead of doing that many steps, directly I have done one element I have taken, multiplied with its cofactor. Next, second element multiplied with its cofactor. Third element multiplied with its cofactor, and the addition is done. By definition, the result what we are getting is nothing but the determinant of a 3 by 3 matrix. So now one example I will do here. Example: find the determinant of A is equals to 1, 0, minus 2, 3, minus 1, 2, 4, 5, 6. For this, you need not find out cofactors separately for any one row elements. So first row I am taking for our convenience. So determinant of A is equals to, there is a formula as if we assume A1, B1, C1, A2, B2, C2, A3, A3, B3, C2. Just now we have derived formula. A1 into B2, C3 minus B3, C2. A1 into B2, C3 minus B3, C2 minus B1 into A2, C3 minus A3, C2 plus C1 into A2, B3 minus A2, A3, B2. Just now I have derived the formula for determinant. This is one method. The other method is find out the cofactors separately for these three elements. Then multiply those respective cofactors to them and do the addition. You will get the determinant. However, is the same. So, however, direct formula we got here. Easy to remember the formula also when we practice few problems, it will be easy to remember the formula. So A1 is 1 into B2 C3 minus 1 into 6 minus B3 C2 2 into 5 minus B1 is 0 A2 C3 3 into 6 minus A2 C3 A3 C2 4 into 2 plus C1 into A2 B3 3 into 5 minus A3 B2. So 4 into minus 1, which is equals to minus 1 into 6 is minus 6, 2 times minus 10 into 1, nothing but 1, minus 0 into whatever is here. No need of simplification, or simplify. 18 minus 4 to the 8 plus of minus, otherwise minus 2 into 3 5 is 15, 4 minus 1 is minus 1, minus 4 of minus plus 4, which is equals to minus 16, 0 into 10 plus 15 plus 4 is 19 into minus 2 is minus 38, which is equal to minus 16 minus 0 into 10 is 0 minus 38. So minus 38 minus 16 is equals to minus 54 is the determinant of a given matrix. So remember that this is the determinant. So either use direct formula or find out the three cofactors and multiply with them and add them. So now I will give you the homework. I will not write the problems on the board for homework. So you need to take from the textbook 3D exercise. Exercise 3D. First bit, second bit. All finding all the determinants only. 3 by 3 matrix determinants only. And the first bit, second bit you need to do. And the next 3E exercise. 3E exercise. 3E exercise. You need to find the adjoint matrices. First bit, third and fourth. Third and fourth. So these problems you take up for today's homework, and the examples also you need to proceed. Okay, right. Thank you very much. So please note tomorrow's class will be started by 8:15 itself. So the other day we missed one class. Instead of that, tomorrow our class will begin by 8:15 and it will end by 9:45. Please note by 8:15 everybody should get ready for tomorrow. Thank you very much. Completed, sir.
ఒక్క నిమిషం చేస్తున్నా అనౌన్స్మెంట్ అన్నారు కదా.